How's it going, everyone? Euler Gonzalez here again, and in today's video we're going to talk about is the React performance. And this is a course taught by Steve Kinney, I think I pronounced that right. He is now the front-end architecture at Temporal, which is a very interesting application, Temporal.io. Yeah, Temporal.io, which is a very interesting solution, because according to their docs, okay, Temporal, it's we're going an abstraction for building simply sophisticated resilient applications. Is that if your application fail, write your business logic as code. I don't care which language you want to use. But if your application create a workflow that guarantee execution, okay? If your application reading in any of this language, as you create a workflow that guarantee the execution of that workflow, Temporal SDK as a cron job, and make your application work. So code activities to handle and retry failure prompts. So this is like some sort of hypervisor around your application. You know what I mean? And those hypervisor or some sort of layer that detect if your application are running correctly. If it's not, then it's going to deploy that into another computer. Deploy your application on your infrastructure. But as you can see here is this: deploy your application code, workflow, and activities on your infrastructure using existing build, test, and deploy tools. Connect your applications to a Temporal services. Again, all of these are marketing, okay? All of these are marketing, but when we take a look now at their products here, write the code you want, not what you are forced to. So Temporal is a durable execution platform. Look at this. Temporal is a durable execution platform that enables developers to build scalable applications without sacrificing productivity or reliability. It is, but again, this is, if in the context of JavaScript, we have something called like the global context execution or the function execution. So each one of those executions contains several property and methods that allow you to work. All right. So, for example, in the case of the global execution, you have now is the thread of execution. So the JavaScript can evaluate line after the another, okay, as well as the global variable environment. So why am I bring this? Why am I bringing here this? Because when they mention here a durable execution platform, it means like some sort of hypervisor, which is a fancy name to say, hey, this is a hypervisor. Durable execution platform. Okay. Common pitfall with durable execution frameworks. As any solution, it has its trade-off. The emerging landscape of durable computing. With the number of solutions proliferating, it's clear the age of durable computing is upon us. How durable execution works, you know. So this is the second part of the series, building reliable distributed systems in Node. In part 1, we went over what durable execution is, its benefits, and what durable functions looks like. In this post, we'll look at how Temporal can provide durable execution. A function that can fail can last forever and doesn't need to store data in a database. Sounds like magic. There must be gotcha. But that's one of the reasons why I mentioned the global execution context. Or in this case is the function execution context. This is a function that can fail, can last forever, pretty much like a daemon in language or in OS, and doesn't need to store data in database. So this is the traditional way, client, server, and worker. Okay, start a function, stop a function, send signal to a query function, get function and result. And the other is that gets task and send result of the task. But that's quite interesting. So the idea here is this durable execution context, and I'm going to stick to this. Durable execution context to enable is lol. Okay, all right, okay, cool. Well, how old is this? 11 months. Okay.
Of the system is understand kind of where it fits. We'll talk a little bit about the history of the project and how Max started.
Yes, it took us probably 15 years to get to where we are.
This, and I think there's been more than just the 5.
But you can run it as a single binary with
I think schedules is interesting. Why are people dealing with cron today? Like you use temporal. I think about kind of like what we can do. That word durable becomes really, really important. And you know, at temporal,
Yeah.
we define this as durable execution.
So in any case, so the idea here is that Steve Kidney, he's working at Temporal, which is now an open source solutions to run a durable execution platform, making developers or allow developers to build scalable application without sacrificing productivity and reliability. This is what they mention. Okay, the temporal server execute units of application logic called workflows in a resilient manner that automatically handles intermittent failures and retry fail operations. Temporal is a mature technology that originated as a fork of Uber Cadence. Interesting. It is developed by Temporal Technology, a startup by creator of Cadence. Oh, but this is something that takes time in the field. You know what I mean? This is something that takes times in the field. Uber Cadence. Interesting. It actually that's originated as a fork of the Uber Cadence. It's a distributed, scalable, durable, and highly available orchestration engine. It's an orchestration engine. It's here. It's an orchestration engine to execute asynchronous, long-running business logic in a scalable and resilient way. And asynchronous, long-running business logic, for example, servers. For example, service workers. That's quite interesting, by the way. Very, very interesting. This repo contains the source of the Cadence server and other tooling, including CLI, schema tools, Bench, and Canary. You can implement your workflow with one of our client libraries. The Go and Java libraries are officially maintained by the Cadence team, while the Python and Ruby clients library are developed by the community. Okay, the official ones are Go and Java. Interesting. So you need to learn Go somehow, some way, sometime, someday. But in any case, this is just a way to describe briefly what is this Temporal. What is this company, all right, that now provide this, which is a fancy rebrand of the orchestration. Okay, but this is a durable execution platform that allow developers to build scalable applications while being productive. In any ways. Okay, this come from a fork of the Uber Cadence. All right, so that's great. That's cool. So that's Temporal. All right, so that's Temporal. Good. So the goal of today's video is to look now at the introduction of the React performance, okay, and that is the preview here.
Hi, my name's Steve Kinney. I'm the head of front-end engineering at Temporal, and this is a course on React performance. In this course, we'll learn how to make sure that you're writing your code in the most performant manner possible. You'll learn how to structure your component hierarchy.
Exactly. So the goal of this is learn how to write your React component in the most performant way possible. Simple. Specific goals is that. So React performance, here we're gonna learn how to, well, exactly, learning how to write React components in the most performant way possible, as a way to complete our knowledge with the complete intro to React, a course taught by Brian Holt, the React intermediate, as a way to how can, and by looking at the complete intro, for example here, complete intro to React, is like, well, look at what is the value proposition of React, which allows us to render components. Okay, it's allowed to, based on the state, I want to generate view out of this. All right, so React allows you to now render those UI elements. So for that, we look at the tools that we need to start to writing our React applications, such as the ESLint, the Prettier, TypeScript, and as well as the model bundler, whether it is Webpack or Vite, all right? And how now we started to look at the React core concepts, such as the JSX, and then the React hooks, the use effect. How can we combine that as a way to create now our components or component compositions, to look at how can we create is lists or conditional rendering, right? Something that we didn't have put up too much at practice, to be honest. Exactly. And now, how? Okay. Yep. And now, all right. So by looking at the other components in React, which is the JSX, the hooks, the use effect, the React compositions, listing components, and how can we make use the React Dev tools, and then the React capabilities, which is React hook, React query, and React router. What is the value proposition of each one of them? How can we start to use them, as well as the special cases, such as React hook forms, context, React hooks form, context, error boundary, as well as portals. So with those core concepts, then I look now at the way of how can we write production ready React applications. And that is by first looking at these advanced use cases, such as the use ref, use callback, use memo, use layout, use ID, use reducer, okay, and how now the documentation actually promotes you to use reducer instead of use state, which is quite interesting, but I prefer to still using use effect so far, but we know that the recommendation actually prefer to use the reducer, okay, as a way to now have much more consistency of what now this state can do. As a way, a reducer is just a fancy name to say here is the function, and here is the action. So reducer here, which is reduce, and here the intermediate, exactly like this. So a reducer is just a fancy name to say, hey, here's the function, here's the function, okay, or here's the state, sorry, here is the state and here is the action, and I want to generate a new bit of state out of this, which is something that we look now on the use reducer, okay, like this. Where now the value proposition of that is that makes state change testable without side effects, and it is very valuable in time and money. You know, for example, using reducer. So you define is your possible states, okay, and if any of those fall out of that by using as a switch, if any of those fall of that, you don't do that anything. So if on any one of them enter into a particular state, all right, now you're going to generate a new state out of this. Traditionally, the way of how we can generate a new state is by generating a new object. That, okay, you can say is that, all right, I want to generate a new object by saying object.assign instead of object.create, because the object.create, what it does is to set the proto reference of that object to points to that object, and we don't want that. So object.assign allow us to do that by saying, hey, first assign an empty object followed by this state that we're receiving, and let's go to change or mutate that in a particular way. If you implement this now with TypeScript, you will get a lot of the benefit of this. So you're gonna have is much more consistency and predictability in your code base. So far so good, right? So reviewing a little bit of this course as a way to allow us to write production ready React applications, is that great? Now that we have this, so now that we look at this reducer or this advanced hooks, okay, use ref, use reducer, use callback, use memo, when to use each one of them, use callback when you want to pass this a callback or a function, and use memo is when you want to memorize data, as well as the use ID and use layout. Again, this is very narrow specific to them. Then we look at tools and techniques that allow us to write this. So for example, Tailwinds that allow us to write these little tiny CSS classes that we can add to our React components. And behind the scenes, because after all, Tailwind is a compiler, it generates an optimized CSS class for us, which is great. Then I look at these advanced techniques like the code splitting. At the end of the day, we want is to minimize is the initial load time by downloading is the minimal amount of code to teach our app to show something to the user while we are loading everything in the background. So for that, we use the lazy from the React. And then we also have is the server-side rendering, which say, hey, we would like the first request rendering on the rendering on the fly, rendering on the server, okay, send it back as a full HTML. So we had all of the content there. So now our crawlers, the search engine crawlers, can now look at the context and say, all right, let me index that for you. So now we have is we don't suffer from SEO penalty. For example, like other rendering modes, like the from like the client-side rendering application or single-page applications. Well, in those cases, you have to make an initial request, wait for all the content to be loaded, show a loading screen usually to the user while you are loading all of the content or all of the JavaScript bundle, and then you can now show something to the user and your app is interactive. Whereas with the server side, well, first we are the initial request, the content is pre-rendering on the server, the user sees something but can't interact that until we are in the background load all of the interactivity, so our application becomes interactive. In other words, we are now downloading all of the HTML content from the server for this pre-rendered content, and then in the client we just replace that with these new versions already interactive, which is the React or Vue. Okay, that's exactly what these frameworks are doing behind the scenes, and this is how now they achieve this server-side rendering mechanism. In any case, so because of that, okay, and then we look now at these two advanced techniques as well as other features of React, like the use defer and use defer, exactly, or low priority re-rendering, okay, like use defer and use transition, and tools like TypeScript. Okay, we didn't dive too much in that. We just only look at how is something that we can migrate from one place to another, but quite frankly we haven't that much learning, whereas in other videos, yes, we dedicate time and energy to actually look at that. For example, the React TypeScript, and understand is, for example, what is the value proposition of TypeScript? What is the end goal of using React with TypeScript in your Visual Studio or in your code editor? For example, Visual Studio Code. And now understand what is or how can we types or component, for example, for our initial components to receive props, for children components, as well as using hooks, and how can we actually use that. But in any case, another feature that we look is the Redux, okay, and how important is Redux here, okay, as a way to manage our app level application in one single place. And now yes, and now all right, okay, and now, all right, also we look at the unit testing, okay, as a way to understand is how can we make use unit testing. What is the end goal of the unit testing? Is to test its behavior, not implementation, and we do that using these libraries like testing frameworks as a way to look at this React component and say, okay, what are the needs that we need to test, for example. And this nice wrapper expose us is some convenient functions. So for example, like find by test ID, for example, as a way to now await for this content when it is loaded, and then, for example, pass some props, check if we're actually in the default state, we are passing is the proper props by default. So that's quite interesting, because as we make this quick overview, and also you looking at the unit testing, testing user interactions, testing custom hooks, and testing mocks and snapshots, okay? And what is why we use a snapshot here, okay? As a way to not only test snapshots for our components, but also for JSONs. All right. And snapshot is something that you do check on GitHub, but you never edit them directly. So, and then testing coverage. Because a lot of people actually look and ask questions like this. And that's quite, honestly, quite interesting. Because at the end of the day, one of the reasons why we are actually recap all of those topics is just as a way to now be able to look at how can we get out the benefit, how can we get the best out of React as a way to solve the client problems. You will learn how to structure your components hierarchy. Okay. Learn how to structure your component hierarchy. Hierarchy.
To make sure that your application performs as performantly as possible.
Okay, how to structure your component hierarchy to make sure that your app performs as performantly as possible. As performantly as possible.
You'll learn how to memoize components using built-in React.
Okay, that's another important thing. Learn how to memorize, because again, I don't know what to do this, and I can combine that with TypeScript, a way to say, all right. Learn how to memorize
Tools. You also manner possible. You'll learn how to structure your component hierarchy to make sure that your application performs as performantly as possible. You'll learn how to memoize components using built-in React tools.
Okay, learn how to memorize components. Learn how to memorize component.
Performant manner possible. You'll learn how to structure your component hierarchy to make sure that your application performs as performantly as possible. You'll learn how to memoize components using built-in.
Okay, you learn how to memorize components built-in. You learn how to memorize component. You will learn how to memorize component using build, of course. You will learn how to memorize component using built-in React tools like callbacks or memorize tools.
In React tools. You also learn how to load code, learn how to structure your component hierarchy to make sure that your application performs as performantly as possible. You learn how to memoize components using built-in React tools.
Using built-in React tools like use callbacks, use Memo, something that I'm quite familiar with. Learn how to memorize components. And memorize is just a computer science techniques that save you computational time. How so? By define a function, and anytime you receive is let's say you want to now calculate is 9 times 9. How is that? 81. All right. The next time you receive this input, which means that the next time I tell you 9 times 9, you get that right. Straightforward. So with the memorization, the idea here is that giving an input and you compute that. So giving an input, you compute that and store this result in some cache. So Next time you call this function with the same input, instead of compute that, instead of taking time to process that, you already have that. So you deliver that. That's one of the beautiful of this memoization techniques. Which is this memoization technique is it was invented by Donald Parker. No, Donald Mitchell. Sorry, Donald Mitchell. Donald Mitchell with do L. Donald Mitchell, which was a computer science. Exactly. It's a Donald Mitchell, computer science and memoization. Memoize. It's interesting. Memoize. Memoize. Interesting. Why don't Donald Mitchell. Okay. Donald Mitchell. Donald Mitchell. I think it's this. It's an AI research during the Second World War. Oh my God. Did I lose my shit? Oh my God. Donald Michi, Jesus, Donald Michi, God damn. Yes, wait, Donald Michi, exactly. Donald Michi, Jesus, I didn't lose my mind. All right, so memoize. All right, and then what's next?
You also learn how to load code just as it's needed, and we'll also
Okay, learn how to load code just as you need it. Using ESD, lazy for that.
also learn a little bit about the concurrent features in React 18. I hope.
Okay, and the concurrent features of React 18. Okay.
Hope you enjoy the course.
And we'll open up the tools and we'll verify what my very fancy screen recording.
Effectively, let's structure components and memoize to avoid re-renderings, load code on demand, and leverage new concurrent features in React 18. Profiler to diagnose and solve performing issues. Profiler, exactly. Profiler to diagnose and solve performance issues. Okay. Okay. Let's get into this. Oh, it's like people actually it's like actually someone is skipping this. Okay.
Hi, my name is Steve. I am the head of front-end engineering at Temporal. We are going to talk about React performance. And performance is a multifaceted thing.
Okay. This course is now outlined as an introduction course. This is the introduction. the React rendering. React, exactly. The React rendering. All right. Reducing rendering. Okay. Reducing rendering. Okay. Context. 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 All right. And then suspense and transition. And then suspense and transition, which is now this advanced. Suspense is one of these special cases. Context, suspense, okay? It's like these special cases. Context, suspense, and error boundary. All right, okay. So let's go to here. Right now I'm gonna take notes out of this course, so you're not gonna see what is this. Okay.
Talk about, right? Like, because like, even if you were trying to make a React app performant, like there are other things that like involve, that are performance React adjacent to the performance of your React application, right? For instance, if you follow every piece of advice in this doc and it's not on a CDN, there's pieces there, right? Like there are other, right? If you were trying to make a performance, and performance is a multifaceted thing to talk about, right? Like, because like, even if you were trying to make a React app performant, like there are other things that like involve, that are performance React adjacent to the performance of your React application, right? A React and performance is a multifaceted thing to talk about, right? Like, because like, even if you were trying to make a React app performant, like there are other things that like involve, that are performance React adjacent to the performance of your React application, right? For instance, if you follow every piece of advice in this doc and it's not on a CDN, there's pieces there, right? Like there are other pieces to performance. So, in this talk we're going to focus mostly on what that means in terms of a React application. And I think it's super exciting because like along the way you kind of learn a little bit more about how React works. And so we'll kind of get into like what we're going to talk about and go over today. I do want to point out that there are not one, not two, but 5 repos because coming up with example apps that like highlight every different thing you want to talk about. Doing that one app turns out is difficult. Doing 5 apps, it's not difficult. Yes, it's easy to cover all things, but then you have 5 apps. So I will put these here now. For people who are tuning in live, they are in the chat. For those of you watching later, they're probably someplace convenient, like below or next to this video that you're watching. But yes, I would right now kind of.
All right, so we got these 5 repos. We got this course website. In fact, this actually don't have any course website. It's just course repos. All right, course repos. Okay. No, I don't need you to be like that. Okay.
We will start. They are effectively in chronological order, so no pressure. But we'll do a few little challenges and exploring adventures with the React developer tools, solve different kinds of problems and like different challenges. One of them I've just hidden the slow part in various places. You can go like suss it out and figure out how to solve for it. And so yeah, we have some practical examples that we can work through in our time together. So let's kind of just like level set, talk about like what are we going to talk about in this course and who is this for and stuff along those lines. Basically, like if you're looking for more insight to actually how React does the thing, right? You're like, I heard something virtual.
Okay, who is this for? Introduction. So who is this for? Okay, who is this for? You're looking for more insight in how React works? You want to build a toolset for diagnosing performance issue in React? You want to learn some best practice when building React application in hope to avoid some performance issues down the road. But I think I want. So you are looking to know more about React. Okay, you are looking to know more about how React works. Okay. You want to build a tool set for diagnosing performance issue in React. So you want to build a tool set. Interesting. Oh, you want to build a tool set for how okay, you want to build a tool set for diagnostic performance. You want to build a tool set for diagnostic performance issues in React. Amen. Totally, man. I mean, in these tool sets, okay, in these tool sets is some techniques. Yeah, tool set. Yeah, tool set. A little tool set is like un cinturón de herramientas. Okay, like a tool set. All right. And okay, a tool set. Great. A tool set. Completely a tool set. Totally. So you're looking to know more about how React works. You also want to know is how to build a tool set for diagnostic performance issues in React. I mean, I want to build this tool set for diagnostic performance issue. Exactly, some sort of techniques. Okay. And you want to learn some best practice for building React applications. Learn some best practice when learning or when writing, exactly, because it's that, when writing React apps. Okay, so in fact this is so okay, here we look at the specific goals, right? So learn how to structure your component hierarchy to make sure that your app performs as performantly as possible. Learn how to structure your components hierarchy to make your React performantly as possible. Okay. Learn how to memorize components using the built-in React tools, something that we have for use callbacks and use Mimo. So far so good. And learn how to load code as you need it. Okay, which is using lazy and concurrent features of React 18. Okay, and learn how to load code just as you need it. That's right. So concurrent feature of React 18, profiler to diagnose and solve performance issues. Exactly. And profiler to diagnose and solve performance issues. That's this one of the things here as a way to recap what are we going to learn here and what we want to get from this course. Anytime you get a particular course, you need to ask yourself, what is the value that I'm getting from this? What is the return of investment that I'm getting from this course? And I'm going to apply that to my life. Is this something that I can apply to a particular field or in my own job as a skill set? And then you can move on to that. All right. But I really love that this little introduction is what is this course for? You want to know more how about the mechanism of how React works? I mean, as well as the tool sets that allow you, or build tool sets that allow you to diagnose React performance issues. Okay, totally. I mean, okay, I mean, and learn some best practice when writing your React apps. Totally, yeah.
Right, or something along those lines. Like we will, in the effort to understand how we can either A, help the performance of our React applications, or B, accidentally hurt the performance of our React applications, right? We are accidentally going to have to learn how React reacts, right?
Yep. Because even if you know, because if you are new to this, you are going to write React apps that are performant or that hurts it. So you eventually need to learn how that works. Totally.
And then along the way, like the kind of core thing is building a tool set for diagnosing performance issues in Reacts, right? And then along the way, like the kind of core thing is building a tool set for diagnosing performance issues in React.
Exactly. So you eventually need to learn how that works, and you.
And then along the way, like the kind of core thing is building a tool set for diagnosing performance issues in.
Exactly, and you along the way build a tool set of. Yeah, you build a tool set for diagnostic performance issues in React, okay, that will lead you to some of the best practice when writing React app. Exactly. Again, this storytelling here is something that is very, very interesting, because it's like, okay, you can start it initially by doing by yourself. Sometimes you write your React applications without any problems. Okay, sometimes you don't. So sometimes you write performance React app. Sometimes it hurts you. You write React app that hurts the performance. So you eventually need to learn how the React works behind the scenes. So along the way, you are going to build a whole set of diagnostic, or you're going to build a tool set for diagnostic React performance issue, okay, and some of the best practice when writing them.
React.
Exactly.
Yeah, React is decently fast out of the box. One of the things I will say is that like a lot of the applications we are going to use are simplified versions, right? Sometimes I had to put it intentionally slow, fast out of the box.
So React is decently. Yeah, React is decently fast out of the box. So React is decently fast out of the box. One of the things I will say is that like a lot of the applications we are going to use are simplified versions, right? Sometimes I had to put it intentionally slow because I'm like, all right, let's put 10,000 rows on the page, right? Most performance issues are usually the accumulation of a bunch of tiny things that happened over 3, 6 months, a year. None of them in and of themselves. Usually the accumulation, I had to put it intentionally slow because I'm like, all right, let's put 10,000 rows on the page, right? Most performance issues are the. So most performance issues are tiny little accumulation.
Usually the accumulation of a bunch of tiny things.
Usually the accumulation of tiny things.
That happened over 3, 6 months, a year. None of them in and of themselves.
that happen. I got this. Most performing issues are usually the accumulation of tiny things that happened a year later. That things that happen a year later, or that happened 6 months later.
Or maybe the one big thing. It is possible to do one big terrible thing that slows down your app, but you usually find that out pretty quickly.
6 months or a year later. It is possible to get a performance issue quickly. Okay, it is possible to get a performance issue quickly, but you will see that much more earlier to fix it.
And there's like, who made the last commit to main? And you kind of reverse engineer from there. I think what is more interesting and probably more practical is the like, hey,
who made the last commit here? And then you can do some reverse engineering.
hey, when we did get init and like whatever, like everything was great. 18 months in, and now we're like, you start the jokes about how you're gonna jokingly rewrite the app, and then eventually the jokes become a not joke thing, right? And so this is stop you from that thing, because like everyone thinks that's a good idea in the beginning. I've done it more than once, it's never a good idea. And then eventually the jokes become a not. Like everything was great, 18 months in, and now we're like, you start the jokes about how you're gonna jokingly rewrite the app, and then eventually the jokes become a not joke thing, right? And so this is stop you from that thing, because like everyone thinks that's a good idea in the beginning, and I've done it more than once, it's never a good idea. And then I think the probably
Oh my god. And a lot of the time people start joking about how they are writing their apps. Oof. Oh my god.
right? And so this is stop you from that thing, because like, and now we're like, you start the jokes about how you're gonna jokingly.
You start to joke about how you're gonna jokingly rewrite the app. A lot of the time people start to joking about how they are about how you're gonna joke about how they are about how you are. Oh my god, this is true, bro. About how you are gonna joking, about how you are gonna joking, about how you are gonna joking, rewrite the app. Oh,
Rewrite the app, and
sneak.
eventually the jokes become a not joke thing, right? And so this is stop
Rewrite
you from that thing, because like everyone
the
thinks that's a good idea in
app.
the beginning, and I've done it more than once, it's never a good idea.
Exactly, and a lot of people start joking about how you are going to. Exactly, and a lot of people start to joking about how you are gonna rewrite the app until it's not funny anymore.
Yeah. And then I think probably the piece that I'm most excited about is as we walk towards those first two bullets, looking at like how to follow React best practices, understanding why they are what they are, right? So you ideally don't get yourself into the situation where you have this like increasingly burdensome amount of bugs you have to find. The nice part about solving these performance issues is the techniques that we're gonna see on these relatively small example apps that are like clear and to the point. Those techniques are the same ones that you use when it's a big like tangled mess of like performance bugs. So like the solving it is just applying it repeatedly. It's kind of like untying a big knot, right? You just start pulling out the threads with the technique you know how to do. And performance bugs, so like the solving it is just applying it repeatedly. It's kind of like untying a big knot, right? You just start pulling.
Okay, interesting. Here we are seeing how to. Oh, okay, it's like untying the knot.
Like tangled mess techniques that we're gonna see on these relatively small example apps that are like.
Exactly. Here we see techniques on how to do that on relatively small apps that apply to bigger apps. It's like applying this. Okay, it's like applying these techniques. It's like applying this technique every time.
Clear and to the point. Those techniques are the same ones that you use when it's a big like tangled mess of like performance bugs. So like the solving it is just applying it.
So it's like applying these techniques over and over and over, regardless the size of your app. It is like unknot. Okay, unknot.
It's kind of like untying a big knot.
Untying. Exactly. It's like untying. Untying. I think this untying. Okay, it's like untying a big knot. Exactly. It's like untying a big knot. Untying. On time, bro. Oh, let me now here. Like untying a big knot. That's interesting. Okay, it's kind of like untying a bit knot. Untying a knot. Kind of like untying a bit knot. It's like you do that with patience. I really love this kind of analogy, man. This is one of the reasons why taking notes out of this course and now write it down, because now I can now enhance my vocabulary, and especially when I need to be precise to describe certain things. And I think that's something very, very valuable for myself and for those around me, especially if you have to talk in a more deeper sense. Because what happens is that a lot of the time, all of this, well, people from the South America, so they are not very good at English, and especially technical communications. And not to mention is about the business. It's like each layer is there's a lot of ignorance there. And again, it's not your fault that the word it is what it is, but it's your responsibility to get it. Anyway. So I love the way how you can now, or in this case, Steve is explaining a little bit. It's like, all right, this is just the introduction of React performance, and the value proposition of this is if you write your React applications at the beginning, you might sometimes write performance React app or hurt the performance. So to prevent that, well, the idea here is to learn about how React works, learn the inner mechanism, and then you're going to see now how you're going to build a tool set of for diagnosing these React performance issues, okay? And along the way, you're going to develop some best practice or techniques that allow you to now, anytime you find yourself in that situations, in something that we're going to see here with these 5 examples, all right? So anytime you look at this particularly or this performance issues, because you already build that tool set, okay? You already build you already build that tool set for diagnosing these kind of problems, and then you come up with some techniques or best practice as a way to solve them. So this kind of techniques that applies this to small and bigger apps is also pretty much like untying a big knot. So you can apply these techniques repeatedly. And perhaps when you're writing your application initially, so performance is something that usually tends to accumulate in a very, very small place until 6 months and a year has passed. So a lot of the time you start joking when you have to yokely rewrite your apps until it's not a joke anymore. And the joke becomes is hours, days, debugging this, looking at this, and how you can now change, and how you can now try to change something is something that takes a lot of time. It's like it's like, oh man, question: Are you doing that? You getting what you want? That's what happened. Anyway, all right, okay. And here, well, we're gonna see is that not only is how you can build these tool sets of now how you can build this tool set for diagnostic React performance by understanding is how the React works, all right, which is something that you can apply for JavaScript. So now that you know how JavaScript works, you can now not only explain that, but also develop some techniques that you can apply for specific cases, particularly in the case of JavaScript, building objects, and then how you can now create objects or reuse previous work, aka inheritance. How you must follow is particularly techniques when you're writing your applications, your Node.js applications, and then what the reason of why we're using, for example, Next.js or Nest.js, you know. So, but again, all of these techniques will allow us is to untie the knot as it is.
When it's a big like tangled mess of like performance bugs. So like the solving it is just applying it repeatedly. It's kind of like untying a big knot, right? You just start pulling out the threads with the technique you know how to do. And like performance bugs. So like the solving it is just applying it repeatedly. It's kind of like untying a big knot, right? You just start pulling out the threads with the technique.
Exactly. It's like untying a big knot. It's like you start pulling out the threads. So that you start to pulling out of the the threads, you start pulling out of the threads with the technique that you know, with the technique, pretty much like you are tying your knots, your shoes, or untie them, okay? With the techniques you know how to do, exactly. So you start to pulling out the thread with the techniques you know how, you know how to do. That you know.
How to do, and that is definitely a running theme around here. Generally speaking, there are, kind of like three major topics, about 3 or 4 major like ways that you can solve for performance issues in React. So what do we learn? We're going to learn about all the caching and memoizing stuff that you see, particularly like the moment you go like React performance into Google, you see these blog posts like throw React memo on everything, right? That's not a good idea. And
Yeah.
the nice part is we will understand what the trade-offs are at that point. It is a toolless thing, right? That's not a good idea. And like the nice part is we will understand what the trade-offs are at that point. It is a tool that sometimes you need to use, and sometimes it is the right choice. But the second bullet of the way that you structure your components and the way that you structure your state sometimes can actually like eliminate the performance problem without having to use like, I'm going to cache this and memoize that. Because one of the themes, and we're going to talk, like I have a slide dedicated to Steve's golden rule of performance, I'll do a spoiler now, which is that not doing stuff is faster than doing stuff.
Not doing stuff is faster than doing stuff. Not doing stuff is faster than doing stuff.
One of the themes, and we're going to talk, like I have a slide
Steve, golden rules.
dedicated to Steve's golden rule of performance, I'll do a spoiler now, which is that not doing stuff is faster than doing stuff, right? And there's corollaries to that, which is doing stuff later is better than doing it now. These work for both life as well as performance.
Except not doing it. This work for both life as well as performance.
Not doing stuff.
Exactly. Not doing stuff is faster than doing stuff. Okay. Especially when it comes to performance, when it comes to be athletes, when it comes to do that kind of thing, and that is like, instead of actually doing this, don't. Performance. For example, if you hit the gym regularly, and then you, for some reason, find a girls, you want to go out and dinner, that kind of thing. It's like, once you do that, all right, and then you, for some reason, you now focus your attention is on her and how you're gonna be with her or get out of this, like, you know what I mean? Taking her out of the dinner, you name it, okay? The idea here is that on the performance, is like, is that what you want? Is that what you truly need to? Okay, because sometimes not doing stuff is faster than doing stuff in terms of performance and in terms of doing something, and instead of decision making here.
Is faster than doing stuff, right? And there's corollaries to that, which is doing stuff later is better than doing it now. These work for both life as well as performance, by the way. And doing. One of the themes that we're talking.
Okay. So the value proposition of this is exactly have a slide dedicated to Steve Golden rules performance. Exactly. And not doing things in case of performance, okay? So the value proposition of performance, not doing things is faster than doing it.
Okay, like I have a slide dedicated to Steve's golden rule of performance. I'll just spoiler now, which is that not doing stuff is faster than doing stuff.
Exactly. Not doing stuff is faster than doing stuff. Not doing stuff is faster than doing it.
Right? And there's corollaries to that, which is doing stuff later is better than doing it now. These words, spoiler now, which is that not doing stuff is faster than doing stuff. Right? And there's corollaries to that.
And there's a corollary to that. There is a corollaries. What is corollaries? Corollaries. Yeah, this is in plural. Corollary. Okay. What? Less common conclusion. Okay, corollary. It's like conclusion. Corollary. A proposition inferred immediately from a proven proposition. Okay, a corollary. Oh my God. Okay. So a corollary is a proposition inferred immediately from a proof proposition here. A corollary here. That's great. Okay. Oh my God. Okay. All right. A corollary. Okay. A proposition. A corollary. A proposition inferred immediately from a proven proposition with little or no additional proof, as something that naturally follows. I really like this expression. It's like corollary. It's something that is natural following. Something that is natural follow. Especially when you provide a statement or a proposition. Okay, statement or a proposition infer from a proven proposition, from a proof proposition, okay, or something that naturally follows. So, for example, we born and we grow up as kids. We become adolescents, adults. It naturally follows. But because it comes from the nature, okay, corollary, okay, and there's corollary, or there is naturally progressions, or proposition that infer from proven, proof proposition, with little or no result, or so there's a corollary, okay.
Which is doing stuff later is better than doing.
Exactly. There's a corollary to that. Doing things later is doing stuff later. Exactly. Doing stuff later is better than doing it now. Doing stuff later is better than doing it now. Doing stuff later is better than doing it now, especially when you defer a task, because we're talking about is decision making. We're talking about is priority. Hey, is this task is a priority? It's not. Why would I do that? Okay, it's like is not doing stuff is faster than doing it. In this case, not doing stuff, not doing priority stuff. Exactly, not doing priority stuff is faster than doing it. Period. There's a corollary. So doing doing stuff later or doing not priority and doing non-priority priority stuff later is better than doing it now. And I really love this. Oh, nigga, oh yeah.
Now, these work for both life as well as performance, by the way. But the act of like checking to see if something's in the cache or memoized, that is a thing, right? And so yes, if it saves you more work than rendering an expensive tree, totally. At the same time, if you structure your code where you don't have to check, well, that's way faster, right? And so we'll talk about like how you can actually not have to use the kind of common performance tools and get better performance than having to use them. Well, that's way faster, right? And so we'll talk about like how you can actually not have to use the kind of common performance tools and get better performance than having to use them. And then React 18 brought a bunch of new like concurrency features, and like for the like weapons grade performance problem that you really need to solve for, and we'll take a look at those brand new concurrency features, a bunch of new like concurrency features, and like for the like weapons grade
The weapons grade performance problem.
that you really need to solve for, and we'll take a look at those brand new concurrency features in React and like how to use them and when they're appropriate. They are definitely the like, okay, I have a very bespoke special issue that no amount of rearranging my components is going to solve. You now have some really great tools for solving that. This is the last slide in the deck. It's also the like fourth or fifth slide, but it's also the 48th slide as well. And so kind of just give you a preview of the end and where we end at the end of this whole story together, which is the kind of like hierarchy that you should follow when solving a performance problem in React, right? One is if you can just structure your components and state in a way that eases the problem, well, that's good because you're not like, other than rearranging your code, you're not doing the memoization, caching, those extra checks, right? So that is
Okay.
really going to be faster, right? And like caching and memoization are solid strategies, but not only do they have a hopefully smaller cost than rendering that entire part of the tree, but like if you mess up caching, you can have weird bugs, right? So it's like you have to hope that the medicine is better than the disease sometimes, right? As they say in the only two hard problems in computer science are naming things, caching,
And naming
validation,
things and
right?
cache validation.
Right? As somebody who had to name a bunch of projects, I definitely feel number one. As somebody who's been bitten by the caching and memoization bugs, I understand number two as well. Then we have some of the newer APIs in React. Suspense is a set of APIs. Really, there's about one of them that you can use currently, which is the idea of like lazy loading components. Stuff like lazily doing data fetching is only available if you use a highly opinionated framework like Next or Remix or something along those lines. So we'll just cover the ones that are generally applicable to React apps today, which is loading components lazily, which who doesn't like doing stuff lazily? And then lastly, we'll talk a little bit about the transition API, which is brand new to React 18, and how and when and why you might use it, as well as like how exactly it works and all those things. So that's kind of where we end up. React looks at
Okay.
but really great tools for solving.
So at a high level, what we're going to cover? Okay. At a high level, what we are going to cover. At a high level, what we're going to cover, exactly. At a high level, what we're going to cover. React has a bunch of tools for catching and memoizing components. But the important thing here is that you can also get a lot of benefit for free just in the way you structure your component. It's like catching and memoizing components. It's like catching and memoizing components. In other words, we're telling React, hey, I want you to store this someplace, somehow. I don't know when, but store that. Usually in memory. Okay? Usually is by relying on JavaScript, by relying on closure. Okay? Because at the end, that's exactly what is going to be used. At a high level, at a high level, what are we going to cover? Catching and memoizing components. Okay.
Special issue.
The structure of your component application. Structure your component apps, your component and React apps, and new concurrency features. In React 18, concurrency features. And here is what we have is this low priority re-rendering. low priority re-rendering. So if we take a look now at the React here, okay, that's right. So we take a look now at the React here, React 18, okay, React API, hooks, components, and API, legacy app, React DOM API, the components, APIs in the clients, and API in the server, as well as this. So here you got the components, common components, like you can use from hooks, from the component I mean. Input option progress selection text area, which are the components that React DOM, the APIs, which is, as we mentioned, is like create portal, floss sync, find DOM node, hydratate. This is part of the server-side rendering, pre-connected, pre-fetch, pre-init model, preload model rendering, and API is the client. Create root and hydratate root and API on the server. Render to node stream, and this is part of the way of how you can now create is this server-side rendering. And this is now rules. You got, but I don't want this in English, in the Spanish. I want this in English. Okay, rules of React. Components and hooks must be pure. React calls components and hooks. Never call components functions directly. Never pass around hooks as regular values. Don't write higher order hooks. In fact, it's just use data with login. Exactly, and then you abstract that for that, and you use that. Hooks should be immutable, exactly, and should not immutable, not mutating. Instead of mutating a hook, dynamically create a static version of the hook with the desired functionality. Don't dynamically use hooks, okay? Don't dynamically use hooks. And rule of hooks, as it is. Do not call hooks inside of that. Only call hooks from React components, from React functions. Exactly. Rules of hooks. And server components and server actions and directive. Legacy REST API, children clone elements, components. This API will be removed in future major version of React. Create ref, create factories, valid element, pure component as function instead of classes. And they're gonna deprecate that. That's quite interesting. That's very, very interesting because a lot of things say we learn from our mistakes and we recognize that we must use this functional component. All right. Oh my God. Exactly. Perhaps you might look some components that actually are using class base. Who knows? Who knows? But that's interesting. That's interesting.
That no amount of rearranging my components is going to solve. You now have some really great tools for solving that. This is the last slide in the deck. It's also the fourth or fifth slide, whatever, fifth slide, but it's also the 48th slide as well. And so kind of just give you a preview of the end and where we end at the end of this whole story together, which is the kind of hierarchy that you should follow when solving a performance problem in React, right? One is if you can just structure your components and stay in a way that eases the problem, well, that's good because you're not other than rearranging your code, you're not doing the memoization, caching, those extra checks, right? So that is inherently going to be faster, right?
This is a slide I'm going to show you at the end, but this is not how you can architect what?
The kind of hierarchy that you should follow when solving a performance problem in React.
Okay.
The kind of hierarchy that you should follow when.
Okay, this is the diagnosed. The diagnosed. The diagnosed step.
A preview of the end and where we end at the end of this whole story together, which is the kind of hierarchy that you should follow when solving a.
Okay, the hierarchy to. Okay. Or the diagnostic steps for performance issues. Diagnostic step for performance issue. You first look at the hierarchy or state. Okay, you can solve a problem with how you shape your components hierarchy or state your components hierarchy on your state. Do that first. If not, check out if you have some memoization. It's a solid strategy only if the cost of checking pays for itself within the time you save rendering. This is now the tool set for diagnostic React performance issues. It's like you start with the state and how do you React components in the hierarchy of this. So the hierarchy or state. Do that first. And then you take a look now at the memoization. It's a solid strategy only if the cost of checking pays for itself within the time you save re-rendering. And the other is using the Suspense API to progressively load your application is a good idea and more good stuff will come soon. Okay. Using the Suspense API to progressively load your application is a good idea. TM. And more good stuff will come soon. And the other is the Transition API. Is there for you when you are really in a pickle. In a pickle. Okay, but again, this is now this hierarchy of how you should look first when you find a React performance issue. Holy shit. Oh my God. Okay.
Performance problem in React, right? One is if you can just structure your components and stay in a way that eases the problem. Well, that's good because you're not other than rearranging your code, you're not doing the memoization, caching, those extra checks, right? So that is inherently going to be faster, right? And caching and memoization are solid strategies, but not only do they have a hopefully smaller cost than rendering that entire part of the tree, but if you mess up caching, you can have weird bugs, right? So it's you have to hope that the medicine is better than the disease sometimes, right? As they say in the only two hard problems in computer science are naming things, cache and validation, off by one errors, right? As somebody who had to name a bunch of projects, I definitely feel number one. As somebody who's been bitten by the cache and memoization bugs, I understand number two as well. Then we have some of the newer APIs in React. Suspense is a set of APIs. Really, there's about one of them that you can use currently, which is the idea of lazy loading components. Stuff like lazily doing data fetching is only available if you use a highly.
It's like the Suspense API is lazy loading.
Or Remix or something along those lines. So we'll just cover the ones that are generally applicable to React apps today, which is loading components lazily, which who doesn't like doing stuff lazily. And then lastly, we'll talk a little bit about the Transition API, which is brand new to React 18. and how and when and why you might use it, as well as like how exactly it works and all those things. So that's kind of where we end up.
Okay. All right. Let's get into this. Let's
There are some
get
do not pass
into
go,
this.
do not collect $200. Like
Wait, what?
there are some do not
What?
pass go, do not collect $200. Like if you're going to worry about the performance of your application without like at least checking these two things, right? Which is one, are you running in production mode, right? So we actually do like local server is in development mode, and it does thing like give you console
Man.
logs and yell at you about things, and like say, hey, you're doing this wrong, and like put extra things.
What in the F you think you're doing? It's like, for real. Chill, bro. History. Restore previous season. All right. And then you got it. No? Okay. Firefox. There you go. All right. Cool. Here we are. React rendering. Kitak. Oh. So right, React rendering. So React rendering. React rendering. Okay. Okay.
And it does thing like give you console logs, and there are some do not pass go, do not collect $200. Like if you're going to worry about the performance of your application without like at least checking these two things, right? Which is one, are you running in production mode, right? So we actually do like local server is in development mode, and it does thing like give you console logs and yell at you about things, and like say, hey, you're doing this wrong, and like put extra things in the React Dev Tools, which is what we're going to look at, and a whole slew of things like that. Again, doing stuff takes more time than not doing stuff. Right? So do not be the person who like pulls down your coworker's branch after this course, pulls it up in development, opens up the tools like, did you see you have like a 60 millisecond response time? It should be 16 because it might not actually be like that in the real app, and then you're going to have to make new friends. So definitely, and the easiest way to tell if your React application is running production mode is if you have the developer tools installed, and it's not, you'll see an angry red like React icon, which is what you want to see in development, right? Because you're in development mode in development. But if you go to like whateveryourcompany.com and you see that, it's time to tweak Webpack configs and make that not happen, right? If you use something like React App, you should get it for free. If you use most of the boilerplates, you should get it for free. I have been bitten by this because like we had the like bespoke Webpack configuration that someone built in 2017, and every upgrade, things happen, right? So it's definitely worth checking that. And like the remedy for that is you just set the Webpack environment to production, right? Whatever it is, it could be whatever got you accidentally in that case is going to be different for everyone, but the solution is roughly the same. Fix it. And then the other one, which you have gotten yelled at in your console when you've forgotten them, because I've gotten yelled at it. I don't think the dev tools just yell at me. Which is if you're iterating over like a list and you're mapping over a list of items to render them, and you don't give each one a key, you'll get yelled at. If you give it something like the index, and we'll talk about why when we get to like a later slide, so that React can keep track of which one is which if they get resorted or one gets removed. If you don't use keys while you're mapping over, use keys don't mean anything, like the index of the array, which is literally going to shift every time the array shifts. That is, the immediate gotcha. That is like, there's not a lot to say other than listen to the warning message in your console, right, and do the thing. Those are the two easy ones that will kind of get out of the way, and those have they don't have those trade-offs of like, if you memoize it, like you could accidentally make it slower because you active memorize. No, these are big wins. There's no downside. Just do them, right? They work. The other thing, if you do not already have it, is to go get yourself the React developer tools. They are available for at least every Chromium-based browser and Firefox. I don't know if they are available for Safari. Even like, it turns out I learned that you can go to the Chrome store in Edge and install the Chrome plugin in Edge, and it works. So if you type in React developer tools, you will find those. And we can take a look at those and install the Chrome plugin in Edge, and it works.
Because Edge, after all, Edge engine browser. What is this? Oh. Oh my God, because Microsoft Edge, holy hell, it's because Microsoft Edge say a fork of Google, oh nigga. It's a proprietary cross-platform web browser created by Microsoft, releases in 2015 as part of the Windows 10 and Xbox. It was initially built with Microsoft's own proprietary browser engine, Edge HTML, and their Chakra engine, Chakra and JavaScript engine. Later on, it was ported to Android and iOS as a fork of the Google Chromium open source project. In late 2018, Microsoft announced it will completely rebuild Edge as a Chromium-based browser with Blink and V8 engine. God, you know. Oh my God, 9 years ago. Damn. The new Edge was publicly released in January 2020 and Xbox platform in 2021. Microsoft has since terminated security support for the original browser, now referred to as Microsoft Edge Legacy. Edge is also available in older Windows versions until early 2023, as well as Linux. Although it was created as the successor of Internet Explorer, remaining available alongside Edge for compatibility until 2023, it was removed in Windows 11. Edge is the only browser available from Microsoft for compatibility with Google Chrome. I mean, however, it includes an Internet Explorer mode aims to fixing compatibility issues. So, but the whole point of this is that this is a fork from the, oh my God, this is a fork from Chromium, Google's Chromium, for Chromium open source, from Chromium web browser. Chromium is a free and open source web browser. God. Interesting. Very, 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 very interesting. That's one of the reasons why this is so fast, because it's a fork of this.
So, if you type in React developer tools, you will find those. And we can take a look at those kind of for a second, just to see how they work and get a sense of them, because I will send you on Vision Quests with those in a little bit. So, if you have them installed, like one, you can choose whether or not you want to see this. I have done this mostly for show. On a normal day, I do like the hide from toolbar. I don't need to see an angry orange React icon as I'm developing, but you know, I'm here for you today. So we've got that, and then what it does is it adds 2 extra tabs to your developer tools. There's Profiler, and there is Components. Components basically gives you a component tree, which is useful, especially because it'll give you the key. It'll let you see like what is being passed, all the state. You can actually like tweak the state in a component. It is very good for developing. It is like not necessarily super relevant for like diagnosing and triaging performance issues, but it's, you know, you get them both together, so like, okay. The one that is of more concern to us today is Profiler. And Profiler kind of works like the Performance tab does in Chrome or Edge or what have you. And the kind of best way to do it is to, you know, when you are ready, you're going to hit this record button and do things, right? Like remove a user, remove a post, add a thing, so on and so forth, right? You can like make some things, move around, and then usually, you know, can you go spelunking for performance problems? Absolutely, but it's tricky, right? Like, just because React is rendering doesn't necessarily mean that it's problematic, right? you should take advantage of the fact that like I have a ridiculous laptop, right? And we'll talk a little bit in 1 second about how to simulate a less ridiculous laptop, right? But like also understanding that like the act of it rendering does not necessarily mean you have a performance problem. But you can kind of see this shows you basically everything that rendered, and this is kind of each interaction, right? So this is like whatever the first thing that I did was. You can kind of see like this is all of the rendering process. We'll talk about what that process is and what these words mean in like a slide or two, but it kind of shows you. And the really interesting part is that not only will it show you like the different components, you hover over it, like what its parent was, you can kind of see all the different interactions that you did, but if you click on one of them, like on this one, you can kind of see why did this render, right? And start to like trace back what the
Okay.
something was rendering that you didn't think should have rendered. So for instance, I know one here, so I'll hit remove, I'll hit record, I'll hit remove on a user, right? And so that triggers like, almost everything, right? And so like there are questions of like, did an individual post need to post comment, right? Like which one of these really truly needed to? And I can kind of figure out why did you re-render? Like there are, obviously this is an example with known performance issues, right? Or known rendering issues at least. And you can kind of like get a sense for what it was, but like it's very interesting that once you know you have a real problem, you should always start with a problem. If you just go surreptitiously optimizing your application, one, you might be wasting your time. Two, you might be causing more problems than you have, right? It usually starts with either my favorite bug report ever, which is it is slow, right? Which is both like, it's also like a question I ask a lot during interviews is like, tell me your thought process around that, because it's one that happens, right? It's a way to start figuring it out. Or even when you're developing a feature, as you're in the middle of coding, you might notice it. So it's always important to start with a problem and then try to solve it rather than go looking for problems.
Mm-hmm.
Figuring it out. Or even when you're developing a feature, as you're in the middle of coding, you might notice it. So it's always important to start with a problem and then try to solve it rather than go looking
Exactly. Start with a problem.
for problems. I believe Rob Pike, one of the creators of the Go programming language, I believe the quote is something like, measure first before you optimize performance, and then even then measure again, right, to make sure, right? Like, and that holds true, right? Yes, we have simple apps, but that does not give you a license to go and just find problems, right? Once you know you have a problem, the easiest one, the one where you know quickly is when you are typing in an input field, and like the keys are not showing up in the input field as you are typing, and they show up all at once. Like that is for me the most classic one where I'm like, I have a problem here. Right? Or like when the browser truly locks up, right? Those are the issues of when it's time to like pull out the tools and like jump in. But these tools are available and they're here and they give you the ability to kind of like begin to like dig in and look, and they're actually incredibly powerful and useful. The other thing that you will notice if you look very closely at my screen, and this I use this when I know that I have a problem, right? What I actually use personally, this is just me, subjective opinion, a lot is if you want to hit remove, see those green boxes flashing everywhere, right? Those are everything that's re-rendering. Right, and so a lot of times, and those will happen. I believe there's a setting actually. You can go into the tools here, record why each component rendered. You got general, highlight updates when components render. I would definitely go turn that on. And then whenever your developer tools are open, and not when they're not open, which is both good for your general web browsing, but also you will think you have the most performant app in your world for a second until you realize you close the developer tools. That will happen to you at least once. Super useful for like just as you're working, like everything is flashing green, like. Again, we're not seeking to solve problems before they exist. We're also not seeking to like ignore our act of creating a problem at the same time, right? Especially if it is one of the no-cost performance remedies. Like for instance, we saw keys, production mode, and the one that we'll talk about in a second is either state management or component hierarchy. Those are zero downside optimizations, while memorizations and the other ones have some cost to them. And sometimes you always have to think about like even the zero cost and performance ones, do they have complexity cost? Because if they have complexity cost, then also it's like, yeah, the code is like a microsecond faster now, and it takes me 10 more extra minutes for a new person looking at this component to read it, I don't know that you made the best trade-off. So we'll kind of talk about and think about those things as we go through. The other thing I want to point down here is just in the regular tools under performance. One thing that React will do once you have the tools installed, if you're running in development mode, is in the regular tools, it will use the user timing API to at least start to annotate some of the different. This one doesn't have particularly slow JavaScript in it, like some of the other ones do, but it will tell you what component was rendering and stuff along those lines. While it won't do that in production, so you get a little more extra information. But the more interesting part, because like I usually use the other one, is if you are on a incredibly fancy MacBook Pro like I am, with like more RAM than I thought they could put in a computer, you can go ahead and hit this little thing here, which is to either throttle your network or throttle your CPU, right? And a lot of times, especially depending on what you're working on, incredibly useful, because what might seem fast like on your computer might not work on like the average like person's computer on coffee shop Wi-Fi, right? And so getting a sense for both of these things of like on a slow network connection and with a throttled CPU, right?
Throttled CPU.
Kind of having empathy for your customers, particularly I personally work on a bunch of developer tooling, right? So like I can make a few assumptions about the computers that my customers are using. But like prior to that, I worked on a consumer product, right? Very different demographics, and like also it's tricky because like while my current customers have faster computers, they've also shamed me for performance a lot faster as well. So like the bar is higher. I just don't necessarily need to throttle my computer as much, but they will show up in my GitHub issues. So awesome. So those are the developer tools, and they're super useful, and we will use them throughout the day to figure out why stuff is re-rendering.
It's because now they're using is profiler and that kind of thing. Okay.
Often do you need to defer to the Chrome DevTools when you work with a React application, whatever the case is? Let's say, when is the React profiler not enough?
I mean, so it's tricky, right? Like, insofar that I'm working on a JavaScript application, so like stuff like the debugger and breakpoints and console logs, like it is tricky for me to like delineate because I'm in them all the time, right? I would say that I still, just generally like did my code behave the way I wanted to, like stuff like the elements and the console and like some of the other pieces are still like incredibly useful to me. I think it's when I know I have a problem. And for me, part of the reason it's really hard for me to answer that question is because if any of the tools are open, I'm still getting those green flashing boxes. So I'm like simultaneously looking at my console and getting information from the React tools at the same time. So it's like, for me, it's ubiquitous in both cases, which is one of the things I really like about the tools.
And thank you. And the second question is, how much overhead does the benchmarking itself add? So let's say if I'm noticing a particular number, do I need to discount it by a certain percent when assuming that it runs properly?
I don't know if there's a heuristic, like it is like multiple times slower, right? Like I've even heard the word exponential thrown around, that sounds like hyperbole, right? But I think it is like saying that it is maybe like 2 to 3 times slower is probably fair.
So the general heuristic I think we could agree on is that if you run it and you see proportionally that this has decreased, that means you've improved, but it probably will be even more performant once you run attributable without the overhead.
Yeah, and like it depends on the size of the code base and stuff like that. There is a way to like build a production, at least in Create React App, there's different ways, like for every different setup, whether you're using Webpack, your own thing. There are various ways to also make a production build that has the profiling in it, right? So you get closer to a real number. And the regular Chrome tools will work on a production build. You just won't get like a cheat sheet to what component it is, right? Like the thing that is costing you all that extra like time is all the information that makes it useful. But yeah, to your point, like, especially if one has a system where they can kind of like they have metrics at like in their build process. Be like, it doesn't necessarily matter if it was 60 milliseconds in developer mode. If it is 12% worse than it was last sprint, that's still a problem. 60 milliseconds in developer mode. If it is 12% worse than it was last sprint, that's still a problem, right? And so the relative numbers are still useful for figuring out if you have an emerging issue. But yeah, it's just one of those things which is the exact number you shouldn't take particularly seriously because it will be inflated. First, we're going to talk about Steve's golden rule performance, which I alluded to earlier and ruined. I forgot that I made that animation because I felt it was that important. And we will talk about the corollaries to doing this, which is not doing anything you don't do is faster. So like preventing renders, but also preventing memoization, prevent renders. Everything that you don't do is faster than doing it. And that's ultimately what performance comes down to. It's not like computers spending extra time thinking and pondering life. It is doing extra work that you have deemed unnecessary, right? Or, as we'll get to at the very end of this course, it is doing work that is necessary at a time that is not optimal. Right? And like where we end at the very end, and just kind of like paint the picture, which is sometimes you're doing a thing that, it takes a lot, right? What the concurrency APIs in React do that we'll see towards the end is they allow you to say like, hey, but first, maybe we react to their actual like typing and clicking, and then we can go back to doing the expensive thing, right? Because that's really what we care about, right? We care that our UI, long things might take long, absolutely, but we want to get to the point where, okay, but like our things shouldn't totally freeze up. Right? We should still respond to keystrokes and stuff along those lines. But yeah, generally speaking, the recurring theme is not rendering is faster than rendering. Not memoizing is faster than memoizing. Loading stuff later when you need it is faster than loading in the very beginning. Yes, right? This is all true. Awesome. And so the corollaries, as I kind of mentioned, not doing stuff is faster than doing stuff. Checking to see if you can skip doing stuff is sometimes actual work that was slower than doing it, right? And this is why the measuring matters. Like, if you think, like, oh, the thing's rendering, it shouldn't totally render. Like, you should look at that and see how much it costs.
Some things for web performance and for life. Not doing stuff is way faster than doing stuff. Component hierarchy in the state management. Checking to see if you can skip doing stuff is sometimes less work than doing stuff. Checking to see if you can skip doing stuff is sometimes less work than doing the stuff.
To stop it from rendering.
Sometimes you can put off doing stuff, suspend. Maybe you do the urgent stuff now and then less urgent stuff later. Okay. On the React rendering. Yeah, because we are looking here as inspect the performance with DevTools. But here we are.
Go and like say, hey, you're doing this wrong, and like put extra things
Exactly.
in the React DevTools, which is what we're going to look at, and a whole slew of things like that. Again, doing stuff takes more time than not doing.
So let me actually clone this as it is. React TypeScript. Here we're gonna see is the React performance. So make dir of React performance. Okay. And instead of the React performance, you're gonna now clone this. Open up this. All right. And there we got it. And then runs it. Because it's using is create React, it say, hey, you need to. It's on the hottest takes and being installed. And then you install this now then you run the project npm star. Okay, and now we can see is what is mentioned here. Here their use, or this is using now PostCSS, all right, Tailwind, that's right. Sandbox, infinite loop protection, true, hard reload and change, and there you got it. But this is using is the create React, exactly. So you don't have any dev server for that. Even though here ESLint is quite complaining about it and say, hey, Mimo is defined but never used, Mimo is defined but never uses some warnings. So if we now take a look at our code here, so he mentioned that components are more relevant for production. Okay. Okay, which is now inspecting the DevTools here. So inspect performance with DevTools. So inspect performance with DevTools. Inspect performance with DevTools. So install React DevTool. Okay. We got two features from this. Component relevant for development, and then the profiler relevant for optimization or for performance. Okay, so this is some of the themes. So now that we, oh my god, no, what is it? No, it's not you, it's this TypeScript example. What? All right. It's like in the profiler that you can see here is like, hey, let me not do this, then remove and see what's going on. And as you can see, first it renders the provider, then the context, all right, Then it follow up the application did not render the application. Okay, and it's interesting because it's telling you that, hey, this component did not render, and now it's saying, hey, this component's render followed by the key, which means that followed by all of these components, all of these nested components, right? Like this. When you have now post key and post comment, post key and post comment, as well as the user. What is the user here? Okay. As well as the user here. Oh, if I reload this. Okay, let's do this again. All right, let's do this. Let's do this. So let me now start profiling here and say remove. Stop. Okay. First, it now exactly the provider, which is this components, this base component, the context here is actually taking 70 milliseconds, which is great. The application did not render, but what is render is the post, as well as this, followed by the post comment and the user. Okay, so this is when it's now rendering it. As you can see, this is how you can see how all of these elements are rendering. So you have now this pause, this component that actually is rendering elements. Okay, that's quite interesting. And as you can see here, the components, what you have is now the post that is rendering all of these elements here, like so. Post.map.suppose. You do this, all right. There's a way to render all of these elements. So you get now this post with this comment, followed by this. This next post, which is here, I think it is. Okay, this is one post. Okay, one post, and then it render is the post comment, and this, and then you get this, another post. It doesn't render anything. Okay, interesting. Okay, it's not the elements that are rendering. Okay, so we got this. Start profiling. Remove the first. And then you can see here the post. Exactly, this is what is rendering, followed by this, and now the post comment here, followed by the comment here, followed by that. And then now when I click there, is actually, as you can see, all of these elements actually are rendering. Is blazing fast, blazing fast. Okay, what caused this update? The provider. What caused this update? The provider. And when we take a look now at the entry point in our index, the provider. So here in the provider, we have some sort of actions that I think. Yes. In the provider, we got some sort of actions. Exactly. You have post, that you're providing as a context. They use reducer as a way to say, hey, this is now the state and the action. Post data. This is now the state is post reducer, which is a function that takes an state and a function post reducer here. From features, post reducer here. That's quite interesting here. Produce from Emer. So run this, produce this state followed by this. Hey, is this action type that I'm receiving is a post add? Create this new object for that and unshift that. And then post remove that and then splice that. Post comment that add and then unshift that. Put that on the first element here. Interesting. That's very, very, very interesting here. Because now it's in your provider here, in your context, that you are now passing that. Holy moly. All right. You're creating now a context here with states and your actions. And by defining your post reducers, which are just functions that takes an state and a function to generate a new bit of states. For example, in this case, post. All right. And the other is user. Post reducers and post actions. And this data is as a JSON. All right. Okay.
Stuff, right? So do not be the person who like pulls down your coworker's branch after this course, pulls it up in development, opens up the tools like, did you see? You have like a. The reason it's really hard for me to answer that question is because if any of the tools are open, I'm still getting those green. Like if you think like, oh, that thing's rendering, it shouldn't totally render. Like you should look at that and see how much it costs to stop it from rendering, because maybe active rendering was faster than memoizing it, right? And that's why we use the tools. Is why we use like objective truth rather than just like I've written a blog post, I should totally do this. And then these things we'll see in the kind of like third chapter of the course, which is putting stuff off is better. And then lastly, like this is new to React 18. In React 17, everything was urgent, right? Well, it's one of those things. Everything was equal, and if everything's urgent, nothing's urgent. And so React 18 gives us the ability to delineate between like this is important, this can wait, and we'll see how to use it in cases where like we're stuck with some kind of issue. So now let's talk about how does React do what it does, right? Because it's really hard to like triage and think about what could be the cause of the issue. If you're like something virtual DOM, life is good, right? And so let's talk about like how when something changes, what exactly goes on under the hood. So React's rendering cycle has effectively 3 phases, and I think we mostly know about them, right? And so we have the
React rendering cycles.
the render phase. And this, I think that the whole, like, it's not necessarily true. It's like, there is a virtual DOM, and like, that was definitely true in 2013. It is increasingly less true at this point. But the process is still, and we'll see this in another slide to see actually how it plays out, which is the rendering phase. Like, our components at the end of the day are a bunch of functions, or possibly JavaScript classes. And so when something changes, because like, once we render the page, if the user never clicks on a single thing ever, you don't have performance issues. It's only, they took some kind of action, or like you had like you're polling for the API every 30 seconds. Like something has to happen to trigger a re-render. Like React does not choose to re-render on its own. Something occurred, either through your code or most likely because the user did a thing. right? They tend to do that on applications, right? And if they never do a thing ever, I wonder why this is a React app and not either A, a server-side rendered app, or B, just an HTML page. Those are super performant, right? You want to solve your React performance problems, that's the way to do it right there. So when something changes, we go through the render phase, which is it invokes all the classes, it calls all the functions, looks at the output.
React
and goes,
rendering cycle.
What's different from last time, right? It gathers up all of those things. And then with the array of things, array is probably overloaded word, with the list of things that have changed since the last time it rendered, it goes and figures out what the most heuristic set of changes, most performance set of changes to the DOM are to make, and it makes those, right? Like, it is one of those things where, yes, if you were going to sit there and handcraft every change on the page, you could probably beat React. But as a general heuristic, it has a set of rules that it applies on what the right thing is to do most of the time, and it works. And that's when it enters the commit phase. It takes this list of changes it needs to make to the DOM, and it does them. It updates the DOM, right? And if you ever use like a ref in React, it also needs to then update those refs, right? Refs are basically references to exact DOM nodes. If it has changed the DOM, it does need to do one more sweep to make sure, like, are all those refs still pointing to objects that exist, and like wiring them all back up. And then we have the commit phase. Implicitly in between commit and cleanup, there is this passive effects phase. That's where stuff like use effect happens, right? And as we know, a use effect could call a set state or back, right? And that's why the dependency list matters and stuff along those lines. Mark.
Where do animations happen, and how does that affect rendering?
Animations depend, right? If it is an animation that is done like through CSS, right, then those actually will a lot of times not happen on the main thread. If you are, on the other hand, like taking a DOM node and like changing a value on it, those are synchronous and they happen during, a lot of times like you will be modifying the DOM. It'll either happen through a series of renders, it really depends if you're doing it on a ref, then it'll happen in the commit phase. If you're doing it by changing the state every second, you're just going to go on this Ferris wheel that's spinning very fast through this entire process. But if it's a CSS class, then it will happen like on a different process altogether. You're just going to go and like you thread. If you are, right, if it is, the dependency list matters and stuff along those lines. Mark.
Where do animations happen, and how does that affect rendering?
Animations depend, right? If it is an animation that is done like through CSS, right, then those actually will a lot of times not happen on the main thread. If you are, on the other hand, like taking a DOM node and like changing a value on it, those are synchronous and they happen during, a lot of times like you will be modifying the DOM. It'll either happen through a series of renders, it really depends if you're doing it on a ref, then it'll happen in the commit phase. If you're doing it by changing the state every second, you're just going to go on this Ferris wheel that's spinning very fast through this entire process. But if it's a CSS class, then it will happen like on a different process altogether. Cool. All right. So let's look at this render phase and how it actually works. Basically, the kind of like high level is we've got this idea of something happened. Usually, almost always, that is some kind of state change. It's either a state change or a prop change, but like what's changed in something's props. Eventually, there was a state change somewhere, right? Like the context could change. A lot of times, there's a use state hiding in that context, right? And as I've talked about before, and we will talk about later, like use state is just an abstraction over use reducer. So if it happens in use state, then it happens in use reducer. So we start out with a state change that triggers a render, and then the heuristic that React uses for whether it should render a child component is did the parent change, right?
Exactly.
So like let me guess, like there's no other heuristic of the state change will trigger on some parent node, right? And then all, right? Heuristic that React uses for whether it should render a child component is did the parent change, right? There's no like, let me guess, like there's no other heuristic of the state change will trigger on some parent node, right? And then all of its children will be asked to re-render, right? And then at the end of that render phase, React will gather them all up before them and be like, who is different now, right? But every single one, regardless.
There's a question around, do these changes batch if there's two separate components?
I love questions that have slides though. I will answer now and then I'll answer it again because like, I'm not going to be rude and not.
Do these changes batch if there's two separate components?
I love questions that have slides though. I will answer now and then I'll answer it again because like, I'm not going to be rude and not answer it now. So the question was,
Separate components.
I love questions that have slides. I will answer now and then I'll answer it again. Because like, I'm not going to be rude and not answer it now. So the question was, what happens if we trigger two state changes, 3, 5, 10, at the same time? And like, do I go through this rigmarole X number of times? And that question somewhat depends on what version of React you are using. If you're using React 17 and earlier, which is a very real possibility for a lot of people, React 18 has not been out that long, and like, sometimes trying to get that upgrade prioritized on the old list isn't the easiest thing to do in the world. There's no shame about that. So in React 17 and earlier, sometimes they were batched. They were batched in an event handler. right? So in and on change, in and on submit, they were batched. There's like a giant asterisk and like 7 other like disclaimers on that. Only in that function. If that event handler had like a set timeout, or I don't know, awaited a promise in an async function, no longer were they batched, right? So in a very small subset of cases, they were batched in React 17 earlier. In React 18 and later, which I guess is just React 18 and whatever minor versions on at this point, like you get automatic batching. Now they are batched across the board in React 18. They will basically run through the code, it will collect up all of the state changes, and then when it's got through that entire process, then it will go and do the next round of state changes. So the answer is it depends. It depends on whether or not you're using 18 or 17, and in 17, I guess if you're using 18, yes. If you're using 17, it depends, right? In a probably the most common case, yeah, right? Like also awaiting promises is relatively common as well. Yeah. The heuristic is if a state change can happen anywhere in the tree, and at that point, it tells all of its children to re-render. Now, really, this graph is like 90% of what we're focusing on today. So there's a bunch of strategies here. One, like right now it's happening at the top of this very simple tree. If you moved it down to one of those, that second row, right, if you can make that state change happen lower, fewer things have to re-render. It doesn't make everything re-render whenever something happens. It says from the point of the state change on down, right? So the further you can push down that state change, which is sometimes antithetical to like what we're told when we're first learning React. It's like, you lift everything up and you pass everything down, but like, don't lift it too high is what this chart is saying, right? You lift it too high, you're going to trigger like a lot of...
That's one of the reasons why, okay. If you define it, okay, oh my God, it's like, exactly, that's one of the reasons why, exactly. If you define a state in a context, it will cause a re-render. That's one of the reasons that, okay. That's one of the reasons that, oh my God. All right, okay, yeah, that's one of the reasons. Yeah, that's one of the reasons why you shouldn't use context. Okay? Because for small apps, all right, that'll be a great use case. If you don't care about that, all of those, anytime you change is the context, it will cause a re-render, no problem, okay? For small app, but for bigger apps, that's a huge penalty performance. And you don't want that. So that's one of the reasons why we say, all right, you know what? No. We prefer is to use this special dedicated store, aka Redux, as a way to now only those components or those states that we define here, this app level state that we define here on slice, for example, okay? All right, so when those states change, whoever child component is make use of them, you're gonna re-render them. Because I don't want to re-render the entire tree here. Makes a lot of sense.
So pushing it down as much as possible, right, is the first and best and arguably not always attainable, but like step one, the first thing that you should try, right? There's like a step two which is like kind of equally as good, but whatever that want to say. Then, if that one doesn't work and the tree is worthy of this, then it is worth saying like somewhere in the middle, can one of you step in and see if this really needs to continue, right? Like just because that one up there started it, like for me and my family, we need like nothing's changed for us, like especially like let's imagine this went down like okay we have a node that ends right there, memoizing that one, pointless. Like the act of doing it is not going to cause a render. But let's say on the right side of the screen that goes down 47 more levels. Stopping that at level 2 or 3 is probably worth it, right? Because like again, React does not try to figure it out. It does not care. It is just going to go, right? So where the cost benefit for any of these techniques come to is like how expensive if we kept going down this path at the place that we could have stopped it, right? Like how expensive would have been and is it worth it? And that's the point where like yeah, at that point you've done the cost benefit analysis. It makes total sense. But doing it on like a tree that's about to end, probably not even worth it, right? Even if it's like, oh, it's re-rendering, it's like okay, like it's fine, like relax. But yeah, they trigger down, they keep going down. So part of it is to push that state change down as far as you possibly can, and the second one is to stop it if you can.
If I recall correctly,
Relax. But yeah, they trigger down, they keep going down. So part of it is to push that state change down as far as you possibly can, and the second one is to stop it if you can.
if I recall correctly, at some point there was in React there was something like if props didn't really change, the component won't re-render.
Yep.
So correctly, at some point there was in React there was something like if props didn't really change, the component won't re-render.
Yep.
So that does not necessarily fit. And I remember I was confused when profiling myself why it wasn't holding true, like what you described held true, but I clearly remember that like as soon as props remain the same, child will not be rendered. How does that?
Yeah, so there's a bunch of ways. One of it we'll do today. So in class-based components there was should component update, right? That was a method that you can put into class one, and that method got two arguments, old props and new props, right? And you could theoretically look at them, right? That was a manual way. We're doing manual way with hooks. Then there was, I believe you could have a class that inherited from pure component, and pure component was basically a subclass of component that had a should component update that said just do even a triple equal sign on these two things, right? Or just shallowly complete a subclass of component that had a should component update that said just do even a triple equal sign on these two things, right? Or just shallowly compare them, and then it would stop it. And I believe for the functional components it might have just been like it might have been like React functional component, or maybe it was like a pure component version. But there was a functional component version as well that did the very shallow should component update out of the box, right? The tricky part to that is, one of the things you always have to think about with performance is that like if it was like you should always do this, right, then they would have just built it into the framework, right? And so what happens is, I'll think about with performance, is that, like, if it was like you should always do this, right, then they would have just built it into the framework. Right? And so what happens is a lot of those equality checks were completely unnecessary, right? Like, again, it is useful because failing one of those should component updates or React.memo or one of the other ones, very high on a tree that has like, you know, great to the like 100th power grandchild, totally worth it. But also calling it on every almost dead end, right, would slow your app down more than it would help. And so what happened was people use those components just as by default, right? Without thinking about it, like, well, that one's better because it checks, right? And then all of a sudden they're doing 1,000 of these memoization checks for gains that were less than the cost of doing the memoization check. So those, I believe, they might even still be in there, I don't know. Like should component update, obviously React.memo, which are the manual ones. But yeah, there are ways to do it, but I would still, even if they are still in there, like warn against them, because doing it everywhere all the time. Now there is, I think there was a talk about a year ago about like someone working on React working on a heuristic, like where they could actually do it when necessary and not do it when not necessary, right? Like we've seen that sometimes not doing it all the time can be problematic. That's our jobs today. We've also seen from like the example you point out, like doing it all the time no matter what, also problematic. But like if we could have a computer figure out when to do it, when not to do it, and get it right 98% of the time, again, the gains would probably outweigh the 2% of the time that it calls a memo when it shouldn't, right? So that's kind of the name of the game. So there is like work on this, and like you think about it, the question that came up before about like batching, right? Like there was a little bit of batching in certain cases, and then there was like automatic batching and it worked. So it's like, it'd be interesting a year from now, 2 years from now, the answer might be like, this is, the heuristic has shipped, right? There's work being done on it. But at this moment, like most of it falls on the things that like, the tricky parts that are left on us with the knowledge of our application, right? Like in the same way we still have to put keys in there because like React doesn't totally know what makes a thing unique. It just needs one piece of information to know if it's roughly the same thing. There's still a few things left on us to do to kind of like inform React about what our intentions are. And so like that's where it comes down to. Like so you're using one of those pure component for the class-based ones, but yeah, using those consistently can be more problematic than not. And so that's just I think an important thing to think about. We won't spend too much time on this, but this is kind of like.
Render phase, commit phase, and cleanup phase.
And overall, like how everything goes down, which is it starts out with a component mounting, which is run the function, call the class, right? Figure out what that
run the function, call the class. Update, use stay, use stuff, use callback. Mounting, use memo, return JSX. Update the DOM, ref, use effect, plus use layout effects, and then cleanup effects.
That's the kind of purple section. Right? You'll get back some JSX, whether it's the render method on a class-based component or the output on a functional one. And that'll all kind of be there. And then like, cool, with the first one, you don't even need to do any diffing, right? It's like, this thing doesn't exist. Go put it on the page. Right on. Right? And that's when it happens in the commit phase. And then after that, which is sometimes why using like use effect for AJAX requests or network requests is somewhat like problematic or tricky, because like you wait until you've done everything and then let's go fetch the data for this component, right? And there's various tricks. Like I think like libraries like Requery use SWR and stuff along those lines. Like I think use SWR will like make a ref that it can cache between cycles. It does some like trickery, right? But yeah, the use effect will happen after you've already committed to the DOM, and then like we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right, a use state or use reducer will go ahead and be the thing the catalyst for the updating phase, right? We'll figure out what all the changes are, we'll trigger that tree, we'll update the DOM again, and things kind of continue and go forward like that. But that is a simplified version of the relatively involved process of figuring everything out. But it is mount the first time and what changed. Cool. The other interesting ones, because we will use them today, is use memo gets set that very first time, and then use callbacks are kind of pulled in to make sure we're not redefining the functions. If you never use those hooks, reduce already committed to the DOM, and then we'll when they happen, and then that's for all not. And so that's just I think an important thing to think about. We won't spend too much time on this, but this is kind of an overall how everything goes down, which is it starts out with the component mounting, which is run the function, call the class, right? Figure out what that original output is. That's the kind of purple section. Right? You'll get back some JSX, whether it's the render method on a class-based component or the output on a functional one. And that'll all kind of be there. And then cool, with the first one, you don't even need to do any diffing, right? It's this thing doesn't exist. Go put it on the page. Right on. Right? And that's when it happens in the commit phase. And then after that, which is sometimes why using use effect for AJAX requests or network requests is somewhat problematic or tricky, because you wait until you've done everything and then let's go fetch the data for this component, right? And there's various tricks. I think libraries like Recquery use SWR and stuff along those lines. I think use SWR will make a ref that it can cache between cycles. It does some trick. Right? But yeah, the use effect will happen after you've already committed to the DOM, and then we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right, a use state or use reducer will go ahead and be the thing the catalyst for the updating phase, right? Where we'll figure out what all the changes are. Simpler version. But yeah, the use effect is I think use SWR will make a ref that it can cache between cycles. It does some trickery, right? But yeah, the use effect will happen after you've already committed to the DOM, and then we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right, a use state or use reducer will go ahead and be the thing the catalyst for the updating phase, right? Where we'll figure out SWR. This thing doesn't want to mount for the class-based ones. But yeah, using those consistently can be more problematic than not. And so that's just I think an important thing to think about. We won't spend too much time on this, but this is kind of an overall how everything goes down, which is it starts out with the component mounting, which is run the function, call the class, right? Figure out what that original output is. That's the kind of purple section. Right? You'll get back some JSX, whether it's the render method on a class-based component or the output on a functional one. And that'll all kind of be there. And then cool, with the first one, you don't even need to do any diffing, right? It's this thing doesn't exist. Go put it on the page. Right on. Right? And that's when it happens in the commit phase. And then after that, which is sometimes why using use effect for AJAX requests or network requests is somewhat problematic or tricky, because you wait until you've done everything and then let's go fetch the data for this component, right? And there's various tricks. I think libraries like Recquery use SWR and stuff along those lines. I think use SWR will make a ref that it can cache between cycles. It does some trickery, right? But yeah, the use effect will happen after you've already committed to the DOM, and then we'll clean up effects which might trigger some stuff. Then, like we said before, in that much simpler version of this, right, a use state or use reducer will go ahead and be the thing the catalyst for the updating phase, right? Where we'll figure out what all the changes are, we'll trigger that tree, we'll update the DOM again, and things kind of continue and go forward like that. But that is a simplified version of the relatively involved process of figuring everything out. But it is mount the first time and what changed.
Mount the
relatively involved process of figuring everything out. But it is mount the first time and what changed.
Mount the first time and what changed.
Cool. The other interesting ones, because we will use them today, is use memo gets set that very.
Mount the runtime and then wait. Okay, all right. Because this model is too dispersed. You are way too dispersed. That is quite interesting to actually catch up all of you.
There are some do not pass go, do not collect.
So give me a sec. Yeah. Give me a sec. Okay. thing. Bonito, ¿verdad? Oye. Well, I think that'll be all for this video. Okay. Take care. Bye bye.